This video is for section 5-2, mean, variance, and expectation for probability distributions. All right, first we're going to look at the mean of a probability distribution. And the formula for that is shown here in the notes and also page 273 of the book. And basically what you're looking at is the mean, mu, is equal to x sub 1 times p of x sub 1 plus x sub 2 times p of x sub 2 plus then on and on to x sub n times p of x sub n. Now, looks a little bit intimidating potentially with the notation, but it's really not that bad. What this says is, for each column in your probability distribution, take your outcome number times its corresponding probability. Do that for every column. Once you've done those multiplications, add them all up. That's your mean. All right, so example 6. We want to calculate the mean and standard deviation for example 3, which was the number of heads you obtain when you flip 3 coins. So if we look at that, transcribe the formula here. So for the very first column, 0 heads. X is 0, the probability is 1/8. Second column, X is 1, probability is 3/8. Next column, probability is 2. Outcome is 2, probability is 3/8. Last column, outcome is 3, probability is 1/8. All right, now, a little bit of algebra. When you have a series of multiplications and additions, you need to do your multiplications first. So 0 times 1/8 is 0. 1 times 3/8, 3/8. 2 times 3/8, 6/8. Whole number times fraction, you take the whole number times the numerator. And then finally, last column, 3 times 1/8, 3/8. Okay, so the 0 falls away when we're adding. We have a common denominator. 3 plus 6 plus 9 is 12. 12 over 8, both those are divisible by 4, reduces to 3/2. Alternatively, you could have done this with decimals. 1/8 would be 0.125, 3/8 0.375, and you could have walked through here and you'd have 0.375, 0.75, 0.375. You'll get your same 1.5 here. No problem either way with the answers, 3/2, 1.5. Okay, so that's the mean or expected value of a probability distribution. Now the variance, the formula looks much worse when you initially look at the notation, but in reality it's very little more difficult than what the mean is. Okay, sigma squared, lowercase sigma, is the variance, equals capital sigma, we're adding something up, and then inside parentheses, x squared times p of x, and then at the end, minus mu squared. Once we have the variance, when we want the standard deviation, we take the square root of that. All right, so let's look at example 6. Once again, what that formula breaks down to is we're going to look at each column, but this time, instead of taking x times the probability of x, we're going to take the outcome squared times its corresponding probability. So you'll see here we had 0, here we have 0 squared. 1, 1 squared. 2, 2 squared. 3, 3 squared. Okay, so inside the parentheses, slightly more complicated than what we had with the mean, but not too bad. But don't forget this minus mu squared at the end. So we have minus 3/2 squared or minus 1.5 squared, whatever you prefer. Again, I'm working in fractions here. The decimals you should be able to convert and follow along. All right, now, exponents take precedence over multiplication. So I went through and 0 squared is 0 times 1/8, still 0. 1 squared is 1 times 3/8, 3/8. 2 squared, 2 times 2 is 4, times 3 is 12 over 8. 3 squared is 9 times 1, numerator is 9 over 8. When you have a fraction and you're squaring it, numerator times itself, 3 times 3 is 9, denominator times itself, 2 times 2 is 4. All right, so we do the addition inside the parentheses. 3 and 9 is 15. 3 and 12 is 15. Another 9 is 24. 24/8 minus 9/4. If you want to go straight to decimals at this point, it's fine. I reduced that down so that they were both in fourths by dividing numerator and denominator both by 2. 12 over 4 minus 9 over 4 is 3/4. So that's the variance. And then the standard deviation is the square root of that. So either the square root of 3/4 or 0.866. Okay, so the biggest mistakes with this are either you lose this minus mu squared somewhere as you're coming down through here. There's a lot of steps there. It's easy to lose that. Don't lose that. And the other thing is stopping here at the variance and forgetting to take the square root to get to the standard deviation if that's what the problem asks for.